Hey guys, it's Miss Johnson, and I'm here to bring you our first notes video for Unit 6. Today we're talking about scientific notation. So we've seen some scientific notation before and have learned how to convert numbers. We're going to do a little practice of that. But more than that, we're going to talk about how we perform operations with scientific notation: add, subtract, multiply, and divide. So let's just refresh our memories. What is scientific notation and how do we write it? Scientific notation is something that we use when we have to write numbers with lots and lots of decimal places. They're either really, really big and they're like in the millions or billions or trillions or even further, or they're really, really small with a lot of zeros after a decimal point. It's just a simplified, more condensed form of writing those numbers. We use base 10 to indicate how many decimal places the decimal point we've moved, because every time you move your decimal point, it's one factor of 10. Similar to saying percent is out of 100, that's 2 factors of 10. 2 zeros, 2 decimal places, 2 factors of 10. So anyways, we're in base 10 when we're in scientific notation. This is what scientific notation looks like. We have a coefficient out front, and then it's being multiplied times 10 to a certain power. 10 to the power of whatever that may be. The coefficient out front needs to be greater than or equal to 1. So this number, coefficient has to be, it's either greater than or equal to 1 or less than 10. And another way that you can think about that is only one number is in front of the decimal point. Okay, so I want only one number in front of the decimal point. And sometimes we have to adjust our exponent depending on what we have so that it looks like that. And then times 10 to the 23rd. Sometimes when you type things into your calculator, you might see, for example, in this case, 6.022 and then E23. That's what your calculator calls scientific notation. So when your calculator, when you see that E, you know that that's telling you times 10 to the power of whatever is behind it. Okay, so if you type these things into your calculator, that's what you're seeing. So let's just talk about writing things in scientific notation. So in number 1, I have 1.1,329,000,000, and I want to write it in scientific notation. Now, for scientific notation, my decimal point is currently here. I need it to be here. I need only one number to be in front of the decimal point. So the question is, how many times do I have to move? 1, 2, 3, 4, 5, 6, 7, 8, 9. I moved it 9 times. Moved it 9 places. So that tells me that my coefficient out front is going to be 1.329. And then I'm going to have times 10. Now the question is, do I have a positive power of 9 or a negative power of 9? And the answer, the best way that I like to think about this is your number really big or is your number really small in between 0 and 1? This case, our number is really, really big, so that's a positive power. If your number is really far away from 0, you're looking at a positive exponent there, positive power. On the flip side of that, in number 2, now I have 0.000068. So currently my decimal point is right here. I want to move it to between the 6 and the 8. That goes 1, 2, 3, 4, 5 places. So I have 6.8. And now I'm looking at a negative 5th power. So it moved 5 times. But my number is really, really small. It's between 0 and 1. So since it's between 0 and 1, I'm looking at a negative power there. And that's my scientific notation. Now in number 3, I have 2,456,789,102. That's a really long number. Now, when you hear things on the news or when they talk about figures for businesses and stuff, they're not going to tell you this entire, say this was a dollar amount. They're not going to tell you this exact dollar amount. They might say something like $2.4 billion. Okay, they're going to round it off somewhere. So what I like to do is I like to look, well, first of all, let's figure out where our decimal point needs to be. Right now it's there. I need to have it between the 2 and the 4. So I'm going over 1, 2, 3, 4, 5, 6, 7, 8, 9 times. So I'm moving my decimal point 9 times, 9 places. And then I need to round this off. I'm not going to write all these digits out. I like to go out to the hundredths place, so that means I'm going to look at the thousandths place to decide what to do with the hundredths, and that gives me 2.46 when I take that 5 and round it up, because 6 tells me to go up. And then I need to put in my power. Now this is a really big number, so I'm going to have a positive power. That's times 10 to the 9th. In number 4, really, really small number. My decimal point's going to be way down here between the 8 and the 9 to give me one number in front of the decimal point. Currently, it's right here. How many places did it go? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I moved 11 places. My pen doesn't like to work on the bottom of the screen. 11 places. So that would be, I'll write in a little better color here, 8.9 times 10 to the 11th. Oh, sorry, hello, negative 11. Really, really small number, negative power, sorry. 8.9 times 10 to the negative 11th power. Okay, so now let's talk about operations with scientific notation. Adding and subtracting is pretty, oh, sorry, we have 4 more to convert. Hello, I'm going the other direction first. So convert these, sorry, I skipped a section. Convert these from standard notation, or from scientific into standard. So now I'm going the opposite way. Now I need to start with scientific notation and go the other direction. So I take a look at my power. That tells me how many places to move the decimal. I'm going to move it 5 times. Since this is a positive 5, that tells me I'm going to end up with a really big number. If I'm ending up with a really big number, I need my decimal point to move to the right. So it goes to the right 5 times. There's 1, there's 2, there's 3. I need 2 more. I fill those in with zeros. 3, 2, 6, 7, 0, 0. Okay. 4.567 times 10 to the negative third. I go backwards 3 places because this is a negative 3 power, which means my number is going to be small. So I need to move to the left. There's 1, 2, 3 would be 2 zeros. So 0.004567. In number 7 times 10 to the 7th power, positive 7 means big number, means move to the right. So I go out 1 and then 2, 3, 4, 5, 6, 7. So that's 1, 2, 3, 4, 5, 6 zeros. 4, 5, 1, 2, 3, 4, 5, 6. 45 million. And here, 3.687 times 10 to the negative 8th. Negative 8 tells me I'm going to have a small number, which means I need to move my decimal point to the left. So I go left 8 places. There's 1, 2, 3, 4, 5, 6, 7, 8. Whoo, 1, 2, 3, 4, 5, 6, 7 zeros. So decimal point 1, 2, 3, 4, 5, 6, 7 zeros, and then 3, 6, 8, 7. All right, now we can talk about operations. So when we're doing operations with scientific notation, adding and subtracting are going to be really similar to each other, but there's a couple of quirks that we have to pay attention to. So first thing, really easy. If the exponents are the same, we're just going to add and subtract the coefficients, and that's that number out front, and then keep the power of 10. Okay, so if they're the same, the power stays the same. Okay, that really helps. But if they're different, this is when life gets a little bit interesting. If the exponents are different, we need to convert them to standard form first. Then we're going to add or subtract, and then we'll convert our answer back into scientific notation. So if the exponents are different, we have a little bit more work to do, but it's still doable. It's still something we can look at. When we're multiplying, we're just going to multiply the like parts. So multiply the coefficients in front together first, and then add the exponents on the powers of 10. This goes back to that unit 3 where we had the product of powers rule. When we were multiplying something like x squared times x to the third, we got x to the fifth because we added the exponents together. That's where that add the exponents theory comes from. And dividing is very similar. Divide the coefficients out front of the powers of 10, and then with division we want to subtract the exponents. So subtract your exponents, because again, when we divide powers, we subtract their exponents. That's another rule that we learned back in Unit 3. So you're going to be using those a lot today. One other thing we need to remember is we need to make sure that our coefficient out front is always greater than or equal to 1 or less than 10. So sometimes that means I have to adjust the exponent. So adjust the exponent as necessary so that the coefficient is greater than or equal to 1 and less than 10. And that's again that only one number in front of the decimal point. All right. So let's flip over to the back and take a look at some of those operations. In number 9, I have 0.37 times 10 to the third plus 4.57 times 10 to the third. So the first thing I recognize is 1, I'm adding. 2, my powers are the same. Lovely, that makes life easy. All I need to do is put those bad boys together. So 0.37 plus 4.57 gives me 4.94. And then I keep my power the same, so times 10 to the third. Here, I still only have one number in front of the decimal point. There's nothing else I need to fix, and that's it. In number 10, I have 2.37 times 10 to the fourth times 3.47 times 10 to the third. Now, a lot of people look at a question like this and think, oh, I have to distribute because this is like FOIL. Wrong. These are multiplication symbols, not addition or subtraction. This is all one term. So really all I'm doing is multiplying the like parts together. So put 2.37 and 3.47, multiply those. When I multiply those out, I get 8.2239. And you can be checking these on your calculator with me to make sure that you're typing them in the right way. So all I did was multiply those two things together. And then that product of powers rule tells me that I'm adding my exponents. 4 plus 3 gives me 7, so this is times 10 to the positive 7th power. That is my scientific notation. In number 11, 9.6 times 10 to the 7th divided by 1.6 times 10 to the 4th. Again, this is just division. I'm going to divide the like parts. So divide those two things and then divide those two things. Those are the powers. And when I divide those, I take 7 minus 4. So 9.6 divided by 1.6 gives me exactly 6. And then 10 to the 7th divided by 10 to the 4th is 10 to the 3rd because 7 minus 4 is 3. One number's in front of the decimal point, so I'm good. I don't have to move anything. I'm good there. Let's take a look at number 12. In number 12, I have 4.82 times 10 to the 4th minus 3.45 times 10 to the 6th. Okay, so I'm back to adding. Actually, in this case, subtracting. But now my powers are different. I got a little more work to do. So let's put these two things in standard form. The first one, 4.82 times 10 to the 4th, I go out 4 places. That's 48200. The second one, 3.45 times 10 to the 6th, I go out 6 places. 3, 4, 5, and then 1, 2, 3, 4 zeros because I moved 2 for the 4 and the 5, and then I got to add 4 more to get to 6 places. Type that into your calculator. 48,200 minus 3,450,000. What do you get? I got negative 3,401,800. Okay, so there's the number that I got, but now it says leave your answers in scientific notation. So I need to go back and put this in scientific notation. My decimal point needs to go there. Currently it's right there. So I need to see how many times I move it. I go 1, 2, 3, 4, 5, 6. So that's negative 3.4018. And then this is a really big number. Now it's a really big negative number, but it's still really far away from 0. So my power is still positive. That's 10 to the positive 6th power. All right, let's take a look at number 13. So in number 13, I have 6.0 times 10 to the 3rd times 2.5 times 10 to the 2nd. So I'm back to multiplication here. I want to multiply the first two things together. When I multiply 6.0 times 2.5, I get 15. And then when I multiply the powers, add those together, I get times 10 to the 5th. Now, here's where we have a slight problem. 15 is bigger than 10. I cannot leave it like that. That is technically not scientific notation. Right now the decimal point is right here. I need it to be right there. So I need to take away, or in other words, divide out a factor of 10. I'm dividing out a factor of 10. Since I'm decreasing a factor of 10 here, I'm moving to the left, so that becomes a 1.5 now. It was 15, so I divided by 10. That means I need to increase my exponent there. Take it away there means increase it there. So now this is times 10 to the 6th, and that is my scientific notation. So you always have to check and make sure that your number is between 1 and 10. Can't have two numbers in front of the decimal point. Let's talk about 7.8 times 10 to the third divided by 1.2 times 10 to the fourth. So when I look at this, I'm looking at division. Divide those two, and I get 6.5 when I just type them into my calculator. And then the other two, the 10 to the third and 10 to the fourth, when I divide those two, 3 minus 4 is actually -1. So that's times 10 to the -1. Now, if you think back to Unit 3 when we worked with negative exponents, a lot of times we didn't want to keep the negative exponents. We wanted to flip them and make them positive. In scientific notation, we work with negative exponents. That's just the way that it goes. So let's take a look at number 15. I have 8.1 times 10 to the -2nd divided by 9.0 times 10 to the 2nd. So divide your like parts. You've got 8.1 divided by 9.0, which gives me 0.9 times 10 to the -2nd over 10 to the 2nd. Here, -2 minus 2 is -4. So that's times 10 to the -4 power. But again, I need one number in front of the decimal point. So now I need to increase a factor of 10. I'm increasing a factor of 10. I'm moving out to the right, which means this needs to go down a factor, or down one number. So this will become 9.0, and the power will become 10 to the -5th, because I need to go down one from -4. And last one, number 16, 6.48 times 10 to the 5th, divided by two things on the bottom that are being multiplied. Now we know that fraction bar is kind of like a grouping symbol. It separates top from bottom. So I have to take care of this bottom first. I'm going to multiply those things together. The 6.48 times 10 to the 5th, I'm just going to leave alone on the top. If I multiply the bottom, 2.4 times 1.8 is 4.32. Well, that's hard to see, sorry. I'll go back to purple. 4.32, and then 10 to the 4th times 10 to the -2nd is 10 to the 2nd, because 4 plus -2 is 2, so times 10 to the 2nd. So this is really what you're multiplying by. Now dividing by. Now divide the like parts. 6.48 divided by 4.32 is 1.5. And 10 to the 5th divided by 10 to the 2nd is 10 to the 3rd. So I had to put the parts in the same position together first, and then I divide across the fraction bar. All right, that concludes our notes video for Unit 6 Notes 1. Thanks for listening, and I will see you all later.